Okay, today guys, we're going to discuss about the division of function. So division of function is represented by this notation, f of g of x, where it means that the f functions, we're going to divide it by our g functions. In this case, we have a restriction that our denominator must not equal to 0. Okay? Okay, let us have here example number 1. We have here given functions 2x plus 6 and g of x is x squared plus x minus 6. So let us find the value of f of g of x. So it means that we're just going to divide the f functions f of x divide by the g of x. So what we are going to do next is we have to substitute the value of our given f of x, which is the 2x plus 6, all over our g of x, which is the x squared plus x minus 6. Then factor our numerator and then the denominator. The greatest common factor of our numerator is 2, quantity of x plus 3. And our denominator is in a form of a quadratic equation. So we know if we're going to factor a quadratic, the result of that is a 2 binomial. And x squared came from multiplying x by x. Okay, so we have here, we have to think of two numbers whose product is equal to negative 6 and sum is equal to 1. Okay, so what is that number? So meaning we are pertaining to positive 3 and negative 2. So in this case, we have to simplify, cancel the common factor, which is the x plus 3, x plus 3. So we have here the remaining 2 quantity of x minus 2, where we have a restriction where the value of x must not equal to positive 2. Because if our x will become equal to positive 2, the denominator will become 0. And if our denominator will become 0, our given expressions will become undefined. So we have here the restriction that x must not equal to positive 2. Okay, so this time let us have example number 2. We have here two given functions. F of x is equal to x squared minus x minus 12. And g of x is 2x squared plus 3x minus 9. So as you observe, our given functions here is in a form of a quadratic equation because our exponent is 2. Okay? So this time, we have to factor a quadratic where the leading coefficient is 1, and we have to factor where the leading coefficient of a quadratic is greater than 1. So how are we going to do that? So let us discuss on this given uh, solution. So in this case, guys, so we have here f of g of x. So it means that we're just going to divide the value of our f of x to g of x. The first step that we are going to do is we have to factor, or we have to substitute the value of our f of x, which is the x squared minus x minus 12, over the g of x, which is 2x squared plus 3x minus 9. So it means that we have to factor our numerator and our denominator. And if we're going to factor our quadratic equation, the result is in a form of E2 binomial. And of course, the same thing in our denominator. So to factor our numerator or our binomial where the leading coefficient is 1, so what we're going to do is we have to think of two numbers. Think of two numbers whose product is equal to the value of the constant, which is negative 12. And if you are going to add the two number is the value of your b value here in your quadratic, which is the negative 1. So this is negative 1. So what do you think is the two number that will satisfy in these conditions? Okay, so the two number will be positive 3 and negative 4, because we know the product of this is negative 12. And if we're going to get the sum, of these two numbers, the result is equal to -1. So it satisfies our condition. Okay? So we have here x squared. So we know this came from multiplying two value of x, which is the x times x, and the two numbers that we got here, which is the +3 and then the -4. How about here, a quadratic in our denominator, where the leading coefficient is greater than 1. So in this case, what we're going to do first is we have to multiply first our leading coefficient to our constant, which is -9. So the result of that is -18. So this is the time that you have to think of two numbers whose product is equal to -18 and the sum is equal to the value of your b value here, which is the 3. Okay? So we have here 3. So what do you think is the two number? Let us say 6 times 3. So we know this is equal to 18. So the result must be -18. So we have to multiply this by -3. So 6 times -3 is -18. And 6 plus -3 is +3. So therefore, we are pertaining these two number, which is 6 and then the -3. So what we are going to do is we have to bring down this first, which is the 2x squared plus 3x minus 9. And cross out the x value here, or the 3x. Then put the value that you got here, which is the 6 and -3, +6, put the variable x, and -3, put the variable x. Then bring down the 2x squared, so this is 2x squared. Then the -9, the -9. So this time, let us do group factorization. So what is the factor of these two? GCF, this is 2x. Quantity of x plus 3. The GCF of this is -3. Quantity of x plus 3. So as you observe, we have here common factor x plus 3, x plus 3. You're just going to copy the x plus 3 common factor and the outside factor, which is the 2x, and then the -3. So therefore, this is now the factor of our given denominator, which is the x squared, x plus 3 rather, and then the 2x minus 3. Okay, so we have here common factor, which is the x plus 3 and x plus 3. We have to cancel this one. Then we have the remaining, which is x minus 4 all over 2x minus 3, where the value of our x, so we have to equate our denominator equal to 0. So 2x minus 3, so it will become to 0 if the value of our x is equal to 3 here, cancel, or we have to transfer the -3, so it will become +3. Divide both sides by 2. So therefore, this is x, which is equal to 3 halves. So here, our restriction, the x value must not equal to 3 halves. Because if the value of our x here become 3 halves, the denominator will become equal to 0. And if our denominator will become 0, the result of this will become undefined. So we have here the restriction. The value of our x must not equal to 3 halves. So this will be our final answer. Okay, so let us have here example number 3. So we have here given f of x is equal to 2x squared minus x minus 6, and g of x is 2x squared plus 13x plus 15. So as you observe, the two given examples here, or the two given functions, are in a form of quadratic since our exponent is 2. And of course, our leading coefficient is greater than 1, which is the 2 here and 2. So how are we going to do this? Or focus on factorization. So in this case, we have to find the value of f of g of x. So this means that the f of x, we're going to divide this by g of x. So the first step that we're going to do is we have to substitute the value of our f of x, which is 2x squared minus x minus 6. And of course our g of x, which is 2x squared plus 13x plus 15. So let us factor or factor this one. And we know that if we're going to factor quadratic, the result is a 2 binomial. The same thing with our denominator. So let us factor first our numerator. Okay? So we have here the 2x squared minus x minus 6. So we have to multiply our leading coefficient by its constant. So the result is 2 times negative 6. We know this is equal to negative 12. This time you have to think of a 2 number whose product is equal to negative 12, and the sum is the value here, which is the negative 1. So what do you think is that 2 number? So this is negative 1. So let us say 3 times negative 4. So we know this is negative 12. And 3 times negative 4 or plus negative 4. So this is negative 1. So it means that we are pertaining these two numbers here. So what we're going to do is we have to bring down our original numerator, which is the 2x squared minus x, then minus 6. Then this time, cross out the middle part, which is the negative x, and put the number that we got here. So which is, I have to write the negative 4 first so that I can factor it here. Okay, so negative 4, then the x variable, and then the positive 3 plus 3 with the x variable. Then bring down the 2x squared, so this is 2x squared. Then this is negative 6. Group factorization, factor this one. The GCF of this 2 is 2x, quantity of x minus 2. And the GCF of this 2 is 3, quantity of x minus 2. So we have here common factor, the x minus 2, x minus 2. We have to write the x minus 2 here. And of course, our outside factor, which is the 2x and the positive 3. 2x and the positive 3. So this is now the factor of our numerator, the x minus 2 and the 2x plus 3. How about the factor of our denominator? So same as usual, we have to multiply our leading coefficient by its constant. So we have here 2 times 15. So this is equal to positive 30. This time, think of two numbers whose product is positive 30 and sum is equal to the middle value or the b part here. So which is, this must be 13x. So this is 13. The sum is equal to 13. So here 10 times 3 is equal to 30. So we have here 10 times 3 is 30. And 10 plus 3 is equal to positive 13. So meaning, we are pertaining these two numbers. Bring down the original denominator, which is the 2x squared. Then the 13x. Then the positive 15. Cross out the middle value and write the two numbers that you got here, which is 10 with variable x and positive 3 with variable x. So this is positive 10. Bring down the 2x squared, and the positive 15. Group factorization. The GCF of this 2 is 2x by x, then plus 5. GCF of this 2 is 3 by x, then plus 5. We have here common factor, x plus 5. X plus 5, write the x plus 5 here. Then, the 2x and the 3, the outside factor, this is 2x and positive 3. So this means that the factor of our denominator is x plus 5, which is 2x plus 3. In this case, we have here common factor in our numerator and then the denominator, which is the 2x plus 3. So cancel the common factor, 2x plus 3, 2x plus 3. We have here the remaining, which is in the form of x minus 2 all over x plus 5. So in this case, we have a restriction where the value of x must not equal to negative 5. Because if our x will become equal to negative 5, so our denominator will become 0. Because negative 5 plus 5 is 0. So this will become undefined. So therefore, we have a restriction here in our answer that x value must not equal to negative 5.